All right, we're going to do a few things here in this video. First, let's take the mass of two blocks with the same volume. So you're going to notice that these two blocks take up the same amount of space. That tells us that they have the same volume. This one is brass and this one is aluminum. Let's weigh the aluminum block first. And it weighs 44.4 grams. It kind of is flipping back and forth on our scale. And then let's compare that to the brass block, which is 137 grams. So notice these two blocks are the same size, but the brass one weighs about 3 times as much. Next, we're going to take the blocks of the same mass, different volumes. So here I have an aluminum block. We'll weigh it. It's 20.1 grams. And notice that it's much bigger than this copper block at about 19.1. So it is a little bit different, but there's a huge difference. Their masses are pretty close, but there's a huge difference in their volumes. Let's measure their volumes. So to measure their volumes, what we need to do is measure the length of one side of the cube. And then we multiply the length of one side by the length of one side by the length of one side. So for the aluminum block, we have a length of 2 centimeters. And so 2 centimeters high, 2 centimeters wide, 2 centimeters long, 2 times 2 times 2 would give us the volume of this block, this aluminum block. If we do the same thing for the copper block, the copper block has a length of 1.2 centimeters. That means it also has a height of 1.2 centimeters and a width of 1.2 centimeters. 1.2 times 1.2 times 1.2 would give us the volume of the copper block. That should get us through the first few pages of Activity 8. In the next part, we will just test copper. So here I have a copper cylinder and a copper block. We already measured the volume of the copper block with our ruler. And if you forget, it weighs 19 grams. Now we can use the graduated cylinder to measure its volume as well. The way a graduated cylinder works is that we can measure the height of the water in the graduated cylinder. And when we put the object in, that water should rise. So right now, the graduated cylinder is showing a volume of 50 milliliters. When I put the copper block in, it has increased from 50 to a little over 52, but a little under 53. You can say maybe 52.5, but not very accurate on that because we can't really measure less than 1 full milliliter. Let's do the same thing now with the copper cylinder. First, let's take its mass. The mass is 56.5 grams. Let's go ahead and put it inside of the water. Note, again, our water height. We're leaving it with the copper block inside, so it's at 52 right now. We'll put the cylinder inside, maybe 52.5. And with the cylinder inside, it rises all the way to 60. It's at 60 milliliters now. And so it's increased by about 7.5 milliliters. With the volume of the water raised and its mass, we should be able to measure the mass or the density of the copper block using both the ruler and the water measurements, as well as the cylinder. Before we finish this video, let's go back to our different blocks, and we're going to measure the mass of a wide variety of materials. But because all of these blocks are the same size, we just have to measure the volume once. So this block's volume its length is 2.5 centimeters. So 2.5 times 2.5 times 2.5 would give us the volume of this block. And then to measure the density, we need the mass divided by the volume. So the mass of the brass is 136.9 grams. We're going to use the same volume for all of these different materials. The aluminum, same volume as the brass, 2.5 times 2.5 times 2.5. But the mass is 44.4 grams. Let's do the PVC. Again, volume 2.5 times 2.5 times 2.5. The mass, 18.2 grams. Let's do the copper. Again, volume 2.5 times 2.5 times 2.5. The mass is 147.7. Let's do steel. Again, mass 127.9, but the volume 2.5 times 2.5 times 2.5. Acrylic, volume 2.5 times 2.5 times 2.5. The mass 16.7. The oak, same volume, the mass 13.2. And finally, the pine, same volume. The mass is 7.5 grams. That's it for this video.